Complex equations are equations that contain two or more variables. You see this all the time when you get into geometry, where you're solving for the volume or the area, even finding perimeter possibly. You have an equation that looks like this. Area equals base times height. You could find the circumference of a square. C equals 2 pi r. There are two variables in this one. There are three variables in this one. So multivariable equations happen all the time. My wife is studying to take the test called the TEAS test. To get into nursing school, you have to have like a 92% or above on this test. You have to average like a 4.0 or above on all your prereqs. Pretty rigorous, and these guys just jump in there. They're not really in the prereqs to get in like to nursing school, but they want you to know this for the test. So these equations will pop into that if you're going into really any sciencey degree. And you've been working with area? We did area of a circle last year, did we? Pi r squared, like very briefly. So it kind of like pops in and out of your math lives. We never really dive into it until you get into geometry. You'll go into a lot more. So the first example, they give us a literal equation for volume. The literal equation for volume is this: length times width times height, or V equals L times W times H. They don't write the L like that because it looks like a 1. The L is a cursive L. It looks like this guy. We're going to rewrite the equation, and they want us to solve for that fancy L. When you have multivariable equations, they just look really intense. And we're going to solve this thing like any equation you've done before with the same methods. I'm going to circle the variable they tell me to solve for. They tell me to solve for fancy L. Circle it. That's the one I want to get by itself. What is happening to this side of the equation with the L, W, and H? Currently, as you're looking at it, what is going on with those three different variables? Wyatt? They're all being multiplied. Any thoughts of how I could get L to be by itself? It's called the inverse. What is the opposite, Tanner? What's the opposite of multiplying? Let's do it. And you can divide by both because they're both being multiplied. If it was like this, which they wouldn't probably write it, but if it looked like W times L times H, you could still divide by WH. That still works because they're all being multiplied. If it was rewritten like that, that's still a legal move. When you divide by WH, remember the inverse operation will cancel it out, and you will get L by itself. On the left side, you're stuck with V on the top divided by WH. That is as simple as you can make the answer. You can't get it any simpler than that. It looks kind of like annoying that you want to make it a better looking number, but that's all you can do. Yeah.
So, what world are we told to do something and there's like zero clue what the numbers mean?
A lot of science-related things when you're trying to isolate a variable and trying to get like different data points and data sets, you're gonna have machines and computers do this in real life. Like I keep saying this in Algebra 1, it's about like the basics. You need behind the scenes to know what's going on and to know how to think about it. When you get to a job in the real world, you're gonna have a computer that does this much faster, but if you have no idea how it even works, you're not going to be even close to getting hired. Cool. Example 2, hired at the job. Any job, except for...
BPS doesn't accept algebra graduates.
You know what I mean. Example 2, the literal equation for density is mass divided by volume, or D equals M over V. Rewrite this equation. It is a real equation for density, and it is written as mass over volume. Rewrite that to solve for the M. Circle the M. And that's the one you want to isolate. Right now, what is happening to the mass and the volume as you look at it, Sarah? It's being divided, so to get m by itself, what's the inverse, Sarah? The inverse is multiplication. On the right side, multiply by v over 1. On the left side, multiply by v. Why would I write the right side as v over 1, but the left is v? Turn and talk to your partner. Get ready. 10 seconds. You're starting. Go.
I keep drawing
3, 2, 1. Why would I write the right side slightly different? They equal each other. These are equivalent variables. Sasha, why would I put the right side as v over 1? It's a fraction and just makes it easier to cross cancel and to look at. You don't have to, but it's a lot simpler to write that as v over 1. I crossed it out, which made a 1 and a 1. M is by itself. You now have your answer. V times d can be rewritten as vd because that means multiply it together. You could also write it as d times v. Either one will work. Whoa. Cool. Example 2 again. What are we doing with this one? Oh, cool. It's the same one. So a sinker on a fishing line is made of lead and has a volume of 0.00000000015 meters cubed. What's the mass of the sinker? Lead has a very high density of 11,340 kilograms. They give you the density, so let's just throw these two numbers into the equation. They tell you that the volume is 0.0000015, and they tell you the density is 11,340, and you're looking for the mass. You just plugged those two numbers in, and you had already isolated for the m, so we can multiply those together. Anyone have a calculator on them? Tony, do you want to throw those two numbers in real quick? You don't need a calculator right now. If you need one in the bronze, I'll get one to you. You don't have one? Okay. Yeah, because the m was isolated here, do you see how it's by itself? Yeah, so you can write it like m equals v times d, okay? Because we're looking for m, they're asking what's the mass. Because you isolated the m, you can just plug in those two numbers and find mass. You know the volume, you know density, multiply volume by density to get your answer. You don't have to divide. Take the equation that is already isolated for the thing you're looking for. Like, you could use that and put d and v into this equation, but it doesn't really make sense if you already have one that's nice and isolated with the m. 0.0000015 times 11,340 is, thanks. Did anybody have a calculator? No? Okay, fine. 11,340. 0.1701. 0.1701 kilograms. The next scenario they want us to get is plastic foam has a very low density of 75. The design for life preserver is 0.3 kilograms of what's the volume of this guy? Cool. So they give us two different things now. They tell us that the density is 75. They tell us the mass is 0.3. They want to know the volume. So let's take the equation you just made. If I wanted to solve for v, what do I have to do to this equation to make it simpler? Tanner, let's try it. Once you divide by d, the volume is isolated, and you get this equation. Your new equation can be plugged in with the mass and the density. Mass is 0.3, density is 75, and your volume for this life vest has to be 0.013 repeating. They have kilograms and kilograms per meter squared. Question, Tony. Meters cubed on this one. When you did meters cubed versus meters cubed, they canceled, and you get kilograms. Same with here, when you divide by kilograms and kilograms, they cancel, and you get meters cubed. Have you guys done formulas like this and find density in science with Mrs. Larkins? You guys were doing the density floats with pennies. Did you have to plug it into the density equation? You used the equation a lot. Did you have to solve for certain variables and move around the variable? So you did the same thing. Awesome. Cool. One more example. Let's do this guy. Interest formula is interest equals principal times rate times time. If you're going to the finance field, interest is going to be something you work with a lot. Find the number of years. Also, it's something that you just should know as a human being. Find the number of years used in calculation of a $1,000 loan at an interest rate of 5%, totaling $600. We want to solve this thing for t first, so let's circle t in our equation. Do you have the next step or a comment?
I have a comment.
Go ahead.
How is 5% 600? Because I don't see how that matches.
It's not. You're looking for the number of years. So you have an interest rate of 5%, a $1,000 loan, and you want it to total 600. How many years do you have to put that money into a bank? Raise your hand if you have heard interest, that word at least. Hands down. Raise your hand if you have actually seen interest on money you own grow, or actually worked on interest with your own money that you work with. Awesome. Hand down. Do you want to explain, Waylon, do you want to explain from your perspective what it does? Cool. And so what that's gonna do in the real life, if you have $1,000, this is a loan, and so this is going to be the type of interest that in the real world they'll say is kind of like bad interest, and you want this number to be as low as possible because you're borrowing money. This isn't the case of what Waylon's talking about. This is $1,000 you're just borrowing. Maybe you need to pay for a really cheap car, or you maybe need to fix something on a house. So when you borrow money from a bank, they're going to say, great, we'll let you have that money, but you need to pay us back with 5% interest. And then that interest is going to be $600. So in the end, you're actually going to have to pay this bank $1,600, but in the meantime, you get $1,000 immediately. That's how interest works in the borrowing sense. In the growing money sense, if you were to loan $1,000 into a bank, so you give them $1,000, you're like, hey, I have $1,000 sitting around. I kind of want to make money on this thing. You have different bank accounts that you can put that in. After a certain amount of years, you're going to have 5% growth on it, and you could potentially make an extra $600 just by giving them money. So that's the good part of the interest, what Waylon's talking about, and what I'd encourage you to look at if you are ever storing money away and looking at savings accounts, that type of thing.
Well, they're saving and investing.
Correct. So two different things. Did we kind of looked at that in the last 2 weeks of school? We had no, we didn't do that.
Yeah, we did. The little magic.
Because they took your Chromebook. That wasn't the same thing though. Yeah. Maybe we'll do it this year. Yeah.
You had a little show and you had hey, bro, I played that game.
I'm gonna pause. I can't hear. Wait, go back. Start over.
So what we're working with, I'm a little confused on how this is working since with the equation it will only go up, but the goal is to get to 6,000. So are we trying to find the actual amount? Oh, 600. But if we're trying to, so are we trying to find the amount we end up or the amount we get?
What we're looking for is the time it takes to get to $600 that we owe. So if you plug in these numbers they give us into this equation, you're going to get a number of years that you would be able to borrow this thing and have to owe an extra 600 bucks.
Oh, so you have to owe it.
Yeah, so the time we don't know, that's what we're trying to find out. And they give us these numbers. $1,000 is the principal loan. Put $1,000 into here. Right. You want it to be 1,600 total that you owe, but the time you don't know what that's going to be yet. So plug in 1,000 for your principal. Principal is the total amount. The rate is your percentage, and you always write percentages as decimals. 5% is 0.05. The interest is totaling 600 bucks. So that's the total interest that you're going to have to pay. Plug this guy into a calculator and it should give us a number of years. Let's do 600. We'll start with this. Times 0.05. 600 divided by 50. In 12 years, you're going to have to pay back the bank an extra $600. Usually that's like in increments, so they'll give you like a monthly check that you'll pay it back in. Determine the interest rate for 2000. Sure. Last one. Now they're looking for the interest rate, the percentage for a $2,000 loan will be paid off in 4 years with interest totaling $640. In order to find the interest rate, solve this for R. Write your interest rate formula, PRT. And how do I rewrite this thing so I solve it for R, Andrew? Before we do that, Andrew, we could plug in the numbers, but let's rewrite this equation so R is by itself. Any ideas how I could do that? Good. And you can divide by P and T even though they're not next to each other because all of this is being multiplied. Okay, so rewrite that guy equal to R. We're looking for the rate. Interest over principal times time. Where? This is the R.
What? Oh.
I circled it.
Oh.
On your homework in your bronze, you should be circling whatever you're looking for. So circle R because that's what we want to isolate. Plug in the numbers for me. What is my interest going to be? The total interest for this guy should be what, Kylie? What's the number of interest? 640. What's the principal for this loan, Elliot? What's the principal? 2,000. That's the amount I'm taking out. And how much time am I trying to put this guy or pay this guy off for, Tanner? 4 years. 2,000 times 4 and divide that by 640. 2,000 times 4. 640. 0.08 is your rate. How can I write that as a percentage, silent hand? Wyatt. 0.08 is 8%, so your 8% is about a standard percent for car loans right now are increasingly high. So right now, taking out a car loan, you're going to probably owe about 8% interest, which is pretty bad. When car loans interest were really low, it was around 4 or 5% to get a car loan. I would not advise you to get a car loan because cars depreciate and are not great assets unless you're a millionaire and can afford it. Car loans are very, very common in America. True. But maybe they're like buying a $5 million car with a pool inside. Okay. Your bronze problems 1 through 6 look like this. You are simply just solving for a variable. You're rewriting it until you get a variable that looks like this. R equals something. When you see it solve for R, circle what you're looking for so you know how to isolate that. When you get to this one, 1/2 BH for B, you may need to check in with your partner and sort out what you do with that 1/2 to get it by itself. Same thing for 4. We'll loop back and talk about 2 and 4 in about 5 minutes. Do your best to try to sort that out with your partner. When you get to 7, you'll have to actually plug numbers in.